I gotta document some last things first and then crash. But all right, what are we looking at here? We've been looking at this running for straight for what, 6 hours, maybe 8. Point being, a ridiculous amount of the bio monomolecule from my blood, like just putting in the 2 drops into this reactor. Now you can see the amount of foam by having the 5 volts going, and probably, hopefully, you can hear the bubbling, almost like popcorn, just from the level of hydrogen. But here is the secret sauce. Yes, this disgusting mix of oxides and hydrides is literally the secret sauce. What am I talking about? Talking about maybe black goo? What's going on? Well, we've got 3 different cups, different electrodes connecting, and obviously a lot less activity in here. But you can see the structured water. You can see also this brownish, reddish, that's a hydride, flowing between the different electrodes. And this guy here, this is actually a barrier. It's not an electrode, it's actually there to prevent the electrodes from touching each other. It's got insulated wire wrapped around it that keeps them apart. But we got three electrodes going in. The one on the right being the cathode, bubbling up. The 2 on the left being a double anode. Okay, but look at how we got it wired there. It goes to one and then the other. Look at the color difference. Pay attention to these things because they are hydrides. And I'm going to also explain why this 5-volt reaction is going so much more than both this one and that one. The second one is about the same amount as the third one, and it's just covered by a lid so you can't see it, but guarantee it is going on. You can see in there with the white on one of the electrodes, the anode there. So thus you know it's active. All right, so compared to the one inside, now this might get me in trouble, but gotta explain the whole process and why you see what you see. This is new water, so it's lighter, it's fuller. Okay, well, just the isotopes are more water. Okay, so the reactor that's inside, when you see it, it's been running for a month. Okay, and atomic hydrogen, the little nanobubble, it sparkles right when it breaks, right at the spot that it breaks its bond from the water, goes up as a gas. Okay, but in the denser liquid water that remains, okay, this is phase shift fusion and DT fusion 101. All right, so the water inside, after running for a month, is a lot heavier. You might even want to call it heavy water. And that is why there's less water isotope molecules left in that solution that are able to split their available extra hydrogen atom into the gas because they've been left with so many extra what we call neutrons from the departing gas hydrogen that has already left it. So if you're listening to what I'm saying, any nuclear scientist, I probably just blowed your mind, but it is that easy. And then the other part of the process here, and why you see this triple over 1, 2, 3. So this is specifically doing reactions to the type of energy flow you're getting into this one. And then the fact that this is a series double anode, and you can see the black, thick material coming off of it that is a hydride. And then you have the oxide being formed on the main connected first anode. It is in that pink crystalline state, as well as some blue oxides on it. And it is also making the CuH3 and the iron FeH3, which is the orange. I guess it's called oxide, but no, it's a hydroxide. So maybe with the iron there might be an oxygen along with the hydrogen, but for the copper that's in there, it goes orange, and it's CuH3. It's a hydroxide. Yeah, so this is a serious electrochemistry, DT fusion, as well as inertial electrostatic confinement fusion, which are both smaller parts of what alchemists fully understood and what I've rediscovered and called valence shell phase shift fusion, or just phase shift fusion. Yeah. Looking forward to talking to Wei Ping Yu about this, because it fits right in with his model. Same with Terrence Howard. We get the red, white, and blue. Shows up a lot. White, neutral. Black, also neutral. White reflects and gives off energy. Black absorbs. It's denser. White's lighter. Opposite ends of the spectrum, just like red and blue. Your ultraviolet, right? Your UV blue, or your infrared. You're expanding out hotter, right? And that has to do with the source code presentation, which you'll get a little bit of before I end this. And come on, y'all. Do you know how many secrets I just gave away that I'm trying to stop saying that so often, but has actually real world gotten many, almost all, probably all of the people up till this point who've talked about this stuff publicly dead. All right, like this is real shit. It's this fucking simple that you can make it in some Wendy's cups, some saltwater batteries, and scrap metal. Again, key part of the genius of my electrodes. You have the ferrite iron inner core, and then you have the copper solenoid. Right, so when you connect the current to the copper wire, it is then creating an electromagnetic field with the iron core, creating a giant electrostatic magnet. And on top of that, I have aluminum and carbon, okay, in between the two. For, well, electrochemists, electrical engineers, people working on battery technology, we'll fully understand exactly how ingenious that really is, especially when you understand, well, the carbon and the tungsten as the inner cores of the electrodes, and then the solenoid wrappings around them, and that's why we've got the solenoid wrappings around them. But yeah, so alright, so here we got, showing again this type of aerogel foam. What up, Plasmist Tantra? You get to be a standard moderator. Everyone gets to be a standard moderator. Alright, so again, we're demonstrating there's some of this yellow as well as the orange. The orange being a H3 compound. But the foam, that is a type of foam aerogel, and that is directly made from when I put my blood, a couple drops of blood into it, and it just starts foaming with your biomolecule. So this is the first basic step of how you then bond your monoatomic field, your resonant field, because it's one, right? So it's one little oscillating of your cell. So that's your energy cell resonating frequency, and then it's bonding with the monoatomics of the metals that you're using. Originally, if you're making monoatomic silver and monoatomic gold, this is the key to then have it integrate and be on your cellular level and frequency with them. And then where I learned this from is from Mehran Keshi, and that you then nano coat your coils, such as which we will show right here. This one is sitting in a caustic solution, but I will also show how to do flame later. So, alright, good demonstration. Why is this copper still copper? That's because it has a plastic coating on it, so it doesn't work. Flame, on the other hand, will solve that. The copper coin down there, it's actually in the pink active state, and you don't want that. You want this black, thick coating on the copper. And see, when it's in there, it goes into the pink state, but when it's out in the air, this is where you get the perfect breakdown of the covalent bonds on the outer side with maximum surface area in a triple solenoid coil. So you got a field within a field within a field of the current, and you have the outer shell broken down, the covalent bonds broken down to one active bond left, right? And what's black? It's the opposite of white. It absorbs, right? So then it's absorbing in the energy. And then when you have plasma, that's the white light coming out, putting out. And, well, actually, the monoatomic is white. So you put in the white coating, and you take the air coating, monoatomic, and coat that, right? So then, well, you have your monoatomic going into bonding with each covalent or atom on the outsides, and yeah, then you got, see, your triple electromagnetic fields perfectly integrated on the nanoplasma field energy density level. And then when you power the triple coils up, the plasma fields electromagnetic triple, because there's a solenoid, solenoid, solenoid. The field within the field within the field gives you the plasma field. And, well, that plasma field is also oscillating on your or my resonant frequency with this guy. But, so you don't want these other impure ones because, you know, they're too dense, they're too heavy, there's too much energy in them. They ignite or they suck down, right? Hydrogen expanding out, hydrides, oxygen magnetic down. The endothermic reaction compared to the exothermic, the implosion being magnetism, the explosion being the original electrical charge. Speaking of electric charge, this is the keyest part of when making your nanocoil. See, it's still active with the caustic down there in the air breaking it down, so it's still technically wet and fully dissolving. Now, when I take this out to dry it, I'm going to connect the voltmeter to it. Why am I doing that? Because as it dries, you're putting the smallest directional charge through the coil. Thus, as the outer shell dries, if you haven't guessed it, it then drives in a unified latticed charge field and makes it magnitudes of effectiveness more and becomes your full metamaterial operating in a full plasma field, especially with the coil within the coil, within the coil, the nanocoating, the monoatomic element with the monoatomic molecule of your biomass. Now, more to it though. There is the red and the blue, and the white is you. The center coil is the black, right? It absorbs. It's your level. It's the level you're walking on, right? It's the plane, and that you cover with the white. Then the top coil you cover with the red hydride, because heat and hydrogen density going up, okay, expanding the explosion up, and then there'll be a third bottom coil underneath that you then coat in the oxide, which is the cold, which is the magnetism that pulls down, it is the blue, and that is your red and blue, up and down, charge, pull, and heat and cold reaction of the white center plasma that comes off the middle, and you've got your two charge polarization quantum fields engraved and well, engineered and put in. And yes, is that advanced? And hope y'all learn something and reproduce this stuff, because as I am demonstrating to all of you, anyone can with Wendy's cups and scrap metal and a freaking USB that's, the cord stopped working, so I just cut her off and boom, look at that. It works. And as I've demonstrated, and don't have time for this, yeah, I obviously got to get some sleep and then get up and get to Albuquerque. But when I'm back from the US, I'm going to demonstrate the same reactor, but without ever connecting it to any electricity. It will just be these three and completely isolated, just so there can be no possible claims of, you're faking, there's a hidden wire. No. It's going to be like these old reactors that are done, but they are keeping the metals in the pink suspended crystalline active state, but they are not active like this because I had them running all last year and they already ran their season. All right. Again, you can observe there's the jelly-like clear water, and then there is the monomolecule hydrides and oxides flowing through the reaction in the third cup. Can you see it in the second cup? Whatever. You don't take my word for it. Why are you here? Yeah. There's the foam. What did I want to show inside? All right. One last chore. Got the perp, so this one you can see it's still kind of suspended a bit. That is because I already used that water and put it on the garden earlier and refilled it, but I didn't do this one yet. This is the ionic gold silver water. All right, so this is the water you pour out. Leave that in because, well, that's was physical 24 karat gold and 99.99% silver. So that is some expensive material. But as I've demonstrated, when you do pour some of that out, say on the lettuce plant, it grew to 6 feet tall. That's going to be in the presentation. The water gives about 2 to 3 times the yield. Okay. Oopsie. Trying to show how you just pour the ionic water. And then you can see it's still in the bottom. Good old agricultural alchemy. We got some little apples growing. Got apples on the ground from the rain. Okay, ozone. And that is how we make the ionic water. Same process with the monoatomics. Ionic water, monoatomics, plasmid purple, that royal purple, that royal purple. Stupid reflection. No, not happening today. Okay. He's on air. Aren't we, guys? And so this could be an acid. This is definitely alkaline. But there is a physical barrier that's developed, self-organized, and established itself between the two layers at this point. And see, up here, running for a month now, you have that dense, heavy water. Right? It's a lot more jelly-ish. And this dense, heavy water. Woo, looky at that, right? That is as alkaline as you can get. Like, that's off the charts alkaline. But is that acidic? Could be. Could be. Son of a gun. Forgot the light outside. Anyways, probably don't need it. You can kind of see the other exclusion zone. Not really. Alright, so this electrode that I put in earlier, a couple hours ago on the last stream. Right, you can see like nothing connected to it whatsoever, but it is still producing constantly. Right, so still an active reactor. And like you got the exclusion zone, even this chunk of metal suspended is staying right below the exclusion, or at the exclusion zone. And the charge difference, it's like you're suspended there. You ain't going nowhere. Okay, here we go. We got lights. We could change the angle. So, you got the original that was yellow, and now this is very interesting, right? It's like one side's yellow, right? And then the other side is green and blue. But that is because of the light, what side it goes through from. It's the opposite. Now you can also see these lines. Those are other exclusion lines that have formed. And you can see the pink crystalline state of the metals at the top of the electrode. And you can see the yellow and blue at the bottom. Now for the real magic. Never demonstrated on camera before. But I guess before we get to that, so that is the white state that the alchemists call the calcium state. It is decay. It is not the white fluffy monoatomic. It is poisonous, and it is, I believe, acidic to the touch. Right, the reaction is still live. Right, this is a live alchemical reaction, and that is because it is still active. It is still trying to self-organize through the alchemical transmutation states of hydrides and oxides, anode, cathode, reaching back to equilibrium, and thus it will be a live reaction for about some of them 3 days, some of them 30 days. Some of them I seal up and engineer where they go on for years actively while still sealed. Okay. The real magic. Just like we saw, the yellow and the blue, here we got what appears to be brownish beige from the front. But no, this is nano gold, my friends. That is nano gold, and it becomes purple from the back when it sparkles, because that is actual gold foil. And that is your purest gold flake you can ever get. And it is purple when the light goes from the back angle. Right, we got purple from the back angle. But then brownish orange from the front. And from above, you see the gold color that it is. That is pure gold flake. Nano crystal. Crystal gold. And here you can see the gold flake here, but that is dropped from there. And so gold flake down there, and then you got gold flake still on the bottle. Clear gold. And this belongs, fuck, I gotta send it to him. My apologies, Francois. I really need to ship that to you. And here's the other one where the gold has also been flaking off. And you have the crystal nano golds at the bottom, or still on the inside of the jars. Again, the gold light from behind. It turns purple. In the front, at right angle, you got gold, straight on brown, orange. And there's one more with so similar sort of effects with the metals when they're in their nano crystal state. This one being copper, but almost could pass as gold. But this is copper, doing a similar sort of thing. And that was from the nano crystal copper. Another type of molecule. Oh yeah. Oh my goodness. This is special. Special type of nano gold. Because that is gold crystals. Actually. Actual crystals. Not nano layering, but actual crystals. Alright. Fuck, I don't know if I should show. I don't know. No, I shouldn't show it all. Never show it all when you're live on camera, right? Never show it all when you're live on camera. See, I was wearing shorts. I didn't show. Oh, there we go. I'm not gonna show what I actually know is tritium, but it's crystallized, and I am not showing that shit. But it's stable because it's in a crystal state. But no, not doing it, not doing it. But that's another time. Anywho, got to go. Love y'all. Have a good day. It's a dark.